Hey, hi folks. So today I will show you. So log4j vulnerability was in the news recently. So you must have heard of it. So I will just show you a little demo of what is it and how we can fix it. And I will also show you how we can track our application that if it is vulnerable to log4j or not. So let's get started. So first of all, so I have created a very simple so it's a Maven project, very basic Maven project. So just so to start with, just add these two so I have added these two dependencies. So these are required for log4j2 logging. Okay, so just add these two dependencies, log4j API and log4j core. And now I have just created a class log4j2. So it has public static void main, and we have a debug logger here. Okay, so it is just saying hello for log4j. Okay, so when I run this, you will see it will try to deserialize this code. So I will not go into details of this. I mean, what was the vulnerability and how hackers can exploit it. I assume you must have seen some videos, so I will just show you. So what I didn't find in the videos. Okay, so when I run this, it will try to look up try to resolve this URL. It will try to hit this LDAP URL and will try to run whatever code is lying in there. So let's run this and see. Okay, so I have run this. Okay, so now so you can clearly see it has print this log stack trace, and it is saying error looking up J&A resource. So it has thrown error because this is simply my localhost, and so obviously it will not work. So okay, so now this is the problem. So okay, so now the next question is how to fix it. Okay, so obviously, so if have you seen the log4j website, so they are saying, so one way is obviously you can upgrade to a newer version. So you can use 216, 217 or 215 point something. So okay, so obviously that will fix the problem. Or if let's say we are reluctant to upgrade to a new version, so you can the next solution is, so you can create a log4j2.component.properties file in your resources folder. So here if you see, just created this file, and this put a property log4j2.format message no lookups is equals to true. So let's say, so first let see what does it do, and then we'll see how does it work. Okay, so what I have done, I have created this file and put up a property, and let's run it. Let's run this again. Okay, so now if I run it again, so okay, now okay, so you can see, so this time it didn't try to resolve this. Okay, so this URL, it just logged it as a simple string. So okay, so that's all. So problem is fixed, so you can ignore this out for now. Okay, so now so this is the another way you can fix this problem. Now you can so how this is works. So you can see this is a class message pattern converter in the log4j core. You must have seen in the log4j website that the problem is specific to this jar. Okay, so log4j core jar. So if you see there, there is a constructor message pattern converter. So there is this it has this property to no lookups, this field no lookups, and it is reading the value from this constant. And if we see, so okay, so you can see this it is reading this value from a property file, and we can see the property file name. So it is log. Okay, so yeah, so log4j2.component.properties. okay, so that's how I got to know. Okay, so this is the this is how you can debug it if somehow this doesn't work for you. Okay, so next let's see how so let's we will move on to some of the how we can check if our application is vulnerable to this log4j or not. So just yeah. Okay, so before actually saying how we can check if our application is vulnerable, I just want to touch upon some basic log concepts. Okay, so but some uses of some basic log jars, so that is necessary to really understand the how we can check how we can trace our application if it is vulnerable or not. So you see, okay, so I have also included this jar, uncommented this jar log4j, slf4j, impl. So you must have known about slf4j. So it is basically a abstraction layer. So it provides some APIs, and both logback and log4j2 implement this slf4j API. So we can use slf4j as our interface, and we can use any of the implementation log4j2 or logback. Okay, so now I have included this jar as well. So now you see, so I have also this class, so slf4j. Now so it does the same. So okay, so if I run this, it will also print this logger statement, and so let's just see. And yeah, so it has also printed this statement. So it has simply print as a string. Okay, because we have set this property. And now and you can see, so let's check the other dependencies. So there is logback. Okay, so let's say I comment it again, uncomment the logback dependency as well. So now any guesses what will happen? So I will show you just in a minute. So if I also uncomment, now logback is also in my class path. Now this will work fine, this log4j. Okay, but if I run slf4j, it will show a warning message. Okay, so why? Because now we have two implementation of slf4j on our class path. Okay, let's check it. Okay, just run. Okay, see, it has said class path contains multiple slf4j bindings. So what does it mean? So it simply it is trying to say that we have multiple logback log implementations on our class path. See, it has also given us the jar file names, this log4j, slf4j, mpl, and logback classic. Okay, so now so this is another point. And now if I comment this one, so it will run fine. Okay, so let's comment the log4j, slf4j implementation. Now we have only one implementation of slf4j on a class path, which is the logback. Okay, so I have commented, and now if I run it again, it will not print any warning message, and it will gracefully print this logger message. Okay, so nice. Okay, so now you can see that even though we have log4j core on our class path, first let's comment this. Okay, and run this hello slf4j again. Okay, now you can see that even we have log4j core on our class path, so it is not trying to look up to that URL, because this is only this vulnerability is only specific to log4j core, and now it is not using log4j core as its dependency. Okay, so now we are using logback. So so this is the reason I have put the class name here. So if you see this sysout println, so it is printing the actual implementation class, which is implementing this logger. Okay, so if you see here, it is logback class logger. Now if I go back and comment this one and uncomment this one. Okay, sorry. okay, and comment this one, and now it will, I think it should now try to resolve that URL. See, yeah, so now you see, so now the implementation is log4j2 and it is trying to resolve that URL. Okay, and the class name here you see is, it is not from logback, it is log4j2 class log4j logger. Okay, so now so now the point that I trying to make is, so it necessarily doesn't mean if we have log4j core or log4j API in our class path, the actual the implementation that we are using decides whether we are vulnerable to this log4j vulnerability or not. So just another point, since now so there are microservices everywhere, and Spring Boot is widely used in microservices. Okay, so I was so Spring Boot we were talking about. So Spring Boot, yes, so in the Spring Boot, if you see that logback, this is the default logging framework that is used by Spring Boot. And let me just show you a class path for a Spring Boot project. And if you see, so this is the all the jar files that is used by a Spring Boot application. So you can get this output by maven dependency tree command. Okay, so if you see here, logback spring logging, yeah, so if you see, it's a logback classic, and so it is in the class path by default. So we include Spring Boot starter web, so or Spring Boot starter parent, so this jar is already there. We don't have explicitly we don't have to add any logging framework for the Spring Boot. So so it is also, I mean, has this log4j to slf4j jar, which internally use this log4j API. So this jar is just there to convert the log4j2 messages to the log4j to logback. Okay, so here we are not vulnerable even if this is on the our class path. So okay, so the purpose of this jar is only to convert log4j2 messages to the slf4j, so that slf4j so that if we are using any other logging framework, we can simply, I mean, provide the implementation of the slf4j, and all log4j2 messages will be converted to slf4j. Okay, so let me just show this as well just quickly. Okay, will not take much time. So let's just, so I have uncommented this. Okay, so okay, another point, this two jars should be on the class path at the same time, since this is the implementation for slf4j and this is converts log4j to slf4j. So it will I mean, it will throw an stack overflow error if both these are present in your class path at the same time. So let me just comment this one, and let me uncomment this one. Okay, so now you see so let me just comment this one also, log4j core. Okay, so okay, now I mean so now what will happen is, if I print any log4j2 message, is it will be converted to logback. Okay, it will be printed as logback. Okay, so let me just run this. Okay, so you can see that so this message, hello for log4j2, so this is actually, I mean, using the log4j API, log4j logger, but it is printed by our logback implementation. How do I know it? Okay, so I have put a logback.xml in my class path, and in the pattern I have put logback, and if you see in the message there is logback. Okay, so now if I remove this, if I comment this, it will throw an error. It will say that no implementation of slf4j is on the class path. Okay, okay, yeah, so failed to load class static logger binder, no operation. Okay, slf4j doesn't have any implementation because log4j messages are being converted to as slf4j by by this jar. Okay, log4j to slf4j. Okay, so I think that's all for this video, and I will try to make more videos that could help in our day-to-day debugging purposes. So that's all. If you have any queries, do let me know in the comment section, and thank you. Thanks.